Hello students, today we will learn numerical differentiation using MATLAB. Okay, so I have already shared with you the numerical differentiation handouts, and it is basically chapter number 23 from Stephen C. Chapra's book, right? So let me take you to the table. This table is for the forward numerical differentiation, and what does it shows? Actually, we have here function, its first derivative at a point xi. Okay, and when we are talking about the forward numerical differentiation, we are saying that I stands for the index, so we are saying that the functional value at I plus 1, functional value at ith point, and divided by the difference between xi plus 1 and xi, which is the step size and which is called h. Okay, and the order of this differentiation is order of h error, right? Error's order is order of h. Similarly, we can go for the double derivative using the forward numerical differentiation. Here we can see that order of h square, first order derivative, and then order of h second derivative and order of h square, uh, double derivative. Okay, and we can derive these formula from the Taylor series expansion. Similarly, here we have the formula for backward. Now let us discuss the backward. For the backward, if I want to find the numerical derivative at the ith location, I will take the difference of the functional values at the ith location and I minus 1th location divided by h. Okay, now we will write the numerical formula, the Matlab formula for these formula. So therefore, it is very necessary that we understand the indices. So let us discuss the indices with the help of a picture. So I have a picture here like this, and I have here x. Let's call it xi minus 1, then xi and xi plus 1. Okay, and remember that these are equally spaced, and the step size here is this distance is called the step size. Okay, and similarly this distance is called the step size, and it is basically equal to h. Okay, so this is basically h, right? So now we are saying that if I want to find the function's derivative at this point, so it is basically the difference between the functional value at ith point and the functional value at I minus 1th point divided by the step size. Okay, so this is the basic understanding of the numerical differentiation, backward numerical differentiation. Now let us go to the centered one. So similarly, we can discuss the formula for the centered numerical differentiation. Okay, so Now, what is most important thing is that for the centered differentiation, we will take the difference between the functional values at the at I plus 1 at point and I minus 1 at point and divided by the difference between a distance between these two locations, so which is 2h. Okay, so we have here f of xi plus 1 minus f of xi minus 1 divided by 2h. Now students, we will write the MATLAB code for this formula, which is the backward formula. So we have already got the book of Stephen C. Chopra. So you can open the book, and from each table, the first formula, we will discuss the MATLAB code for each first row of each table, right? Forward, backward, and centered. Okay, so let us develop a MATLAB code for that. So now for that, we need a function, we need its derivative, and we need the input for the x. X is the independent variable and EQ is a function which is the dependent variable. Okay. Now, whenever we write, let us first define the constant a, which is 2 pi, and then we have a function which is EQ is equal to at the rate of x sine ax plus cos ax. Okay, now this is the most important thing. Why have I used at the rate x? So I'm saying that uh, it is depending on x, right? So it is at the rate of x, right? Now DEQ. Now how did I find the derivative of this function? So that is very easy. We can always find the derivative of a function. And how do we find it? For that, we will first write another M file, or you can write even in the same, but let us, to be more explicit, let us write another M file. Now, how many unknowns are there? We can see that here we have x, y, and a, and we have defined them using the command s, y, and s, and y is equal to sine ax plus cos ax. And I want to find its derivative using MATLAB. I know that I can find the derivative analytically, but if I want to find using MATLAB. Now, if I want to find the first order derivative, I will write here 1. I want to differentiate this function y, so I will write here y. I want to find it with respect to x, d by dx. So I will mention here x. Okay, so these are the three important commands. First, declare the variables. Second, write the function. And third, write the derivative command. And now press, and you can see that your result will appear in the command window. Why will it appear in the command window? Because I haven't put the semicolon here. So you can see that this is exactly the same as I can obtain analytically, right? Now let me take you to the M file where we will find the numerical derivative using forward, backward, and centered schemes. Okay, so the first step is to declare the function. This is the function and this is the analytic derivative. So let us write here. So analytic derivative, okay, using diff command. Okay, now I will give the give input of independent variable. Okay, next is I am saying that this function, my function is depending on x. I know that, but I just for the pre-location, For better speed of computation, I have just given it new name capital F, right? Next, I have the step size h, which is x2 minus x1, just like this. The step size is always the upcoming point minus the previous point. Okay, next I have now typed here the x for different formula. For example, I have showed you the three formula, the forward, backward, and center. So the first thing that I've showed you is forward, right? For the forward one, I'm saying that x is from the first x value till the second last value of x. Let us understand it with the help of the command window. So let me take you to the command window. I'm saying that x is linspace 0 to 4 101. This means that I have 101 values from 0 to 4. Okay, and we have here the x data revised for the forward numerical differentiation. Okay, so I will write it here. I want to see how does it look like. So you can see here, students, it is an array and it stops at 3.96. And what was the actual x like? If I want to see that, it was the ending point was 4. So now by this command, I have omitted the last point. Why have I done that? Because I'm talking about the forward numerical differentiation. So I want to find the numerical derivative. For example, let's say I have a line and I have different points here. So let's say I have this point, this point, and so on, different points here on this line and equally spaced. Okay. So what am I actually saying is that whenever we use the forward differentiation, if I want to find a derivative at this point, I need the information at the I plus 1th point. If I want to find f dash of xi, I need the information at f of xi plus 1. So I will only stop for the inputs here, so that if I stop here, let's say this is x9. So if I want to find f of x9, I will have information at f of x10. Okay, but if I want to find f dash of x10, you can see I do not have any information at f of x11. That is why the rule is that for the forward differentiation, for the inputs, we will always stop one step before the terminating point. Okay, so this is the x input for the forward differentiation. For the backward differentiation, let us look at the x input. Can you see here, students? It is starting from the second point and ending at the ending point. So we will now remove this point. Why? Because for the backward differentiation, if I want to find f dash of xi, the formula is f of xi minus f of xi minus 1. Okay, so if I want to find the derivative at x2, I need the information at x1. Similarly, if I want to find the derivative at x10, I need the information at x9. So that is why we will always take care of the input for x using the MATLAB commands. Whenever we use the MATLAB commands, keep in mind that there are some preconditions for the forward differentiation, for the backward, and for the center. All right, so now I suggest that you type these values just like I have done here to check For example, here I have checked what was the output. So similarly, you can always check it, right? And similarly, I have given the input for the central as well. Now you can see that for the central, I have removed the first point and I have removed the last point of the array, and the remaining values of x I considered. Okay, let me show that to you. Let us write it here. Now you can see that my answer is, I have not considered 4 here, and similarly I have not considered 0 here, and here I have, my step size was 0.04. Okay, this was the information about the inputs for x for the 3 different numerical formula: back, forward, backward, center. Now let us write the numerical formula. That is very straightforward. We will simply follow the same procedure and the formula that I have showed you in the table. And now the plan is that we will find the numerical derivatives at each and every point. For example, I will find f dash of x2, I will find f dash of x1, I will find f dash, and so on. So I want to write a generic formula, So I have now written here functional value at 2 minus functional value at 1 divided that. Then functional value at x3 minus functional value at x2 divided by it. Remember that the double dot means that you are saying that from 2 till, let's say that the end was 100, then you are saying that 2 till 100. So 2, 3, 4 up to so on till 100. Okay. So that is how we will write the MATLAB formula for the forward, for the backward, and for the central. You can see that for the central, it starts from the third index and it ends at the end for the first one, and then for the second one, because usually for the central difference, what do we do? Let us go to the formula. So for the central one, we have here xi plus 1 minus xi minus 1. So let me show you here how we have projected this in the M file. You can see here that for the central you have 3 minus 1 similarly, and then you can see here and minus 2. Why? Because we have to keep in mind that the step sizes of 2h. Okay, so that is why we have designed the formula likewise. For example, 3 minus 1, then here you will have 4 minus 2, then you will have uh, 6 minus 4, and so on. Okay. So now let us see what we get. Now I want to plot the results. Okay. So how am I going to plot the results? Now I have this as the input function. Then I have the derivative, okay, and that is the analytical derivative. So this is the plotting. Let us write here plot the actual derivative, right? Next, here I am going to plot the numerical derivative using central scheme and so on. Okay, now I have given them colors, right? For the actual one, let me give it a blue color. Okay, so I'm saying that now I have got the graphs for the analytic answer, numerical answer using the central scheme, and numerical answer using the forward scheme, and numerical answer using the backward scheme. Okay, with the help of the legends, I can give them the name. Okay, and now I'm going to plot them. So let us look at the graph. Now students, you can see that this is the output, and now we need to zoom it in to check the difference between the numerical answer and the analytic answer. Okay, so now I'm going to zoom in any part of this graph. So can you see here students, the analytic result is the blue one, and central one is the red one, forward one is the black one, and backward one is the green one. And you can see there is error. Yes, why do we have the error? Because it is only the order of h or order of h square scheme. That is why. And as we improve the error order for higher order derivatives, we will get the better results, better accuracy. Okay, and of course we have got the truncation as well when we used to the Taylor series expansion. So for that reason we got the error, but you can see that how nicely we can plot the derivative, the analytic derivative and the numerical derivative. And remember that if we want to straight away find the numerical analytic derivatives, so Matlab is user friendly. It will help you. All you need to do is you need to declare the variables, then the function, and then the derivative. For example, let's say if someone wants to find the analytic derivative, the second derivative, double derivative, so all you need to do is the function with respect to what and of what order. Okay, and then the diff command. So let us press and see what we get here. So you can see this is the double derivative. Okay, so even you can find the 10th derivative as well using MATLAB very quickly. Okay, so this is the utility of MATLAB. Now the homework for this week is you will change the function. Here all you need to do is you will change these inputs, the three inputs. The rest of the commands will remain the same. Or even if you want to change the x input data, better you can change x as well. Okay, watch the video carefully, redefine the input function. Of course the derivative will change, and of course if you have defined a logarithmic function or so on, you will change the input for the x as well. Okay, and then apply the formula. The formula should remain the same here as I have typed, and then you will plot the graphs and you will share with me the graph and the group assignment as a Word document to the email address I have already shared with you. Okay, so thank you so much for watching, students.